Okay, folks, so here you have problem 1 from the homework assignment from week 1, and you can see the scenario that we're trying to figure out is that we're attempting to ladder this window at mid-height. So perhaps this would be a ventilation operation where we're going to try and get on the upwind side, ladder the window at mid-height or above so that we can smash the glass out. And the question is, if the ladder's 40 feet in length, what is the vertical height that we can get to with the ladder? So you can see they've given us a diagram, and 50% of getting this problem solved is it's a matter of having a good diagram. So let's label what we know. We know that this is 40 feet because it's given in the problem, and that's the length of the ladder in this direction as a chord. Other things that we know is that we know that this building is truly plumb, or at least we would hope so, and we know that the ground plane is truly level. And if a building is plumb and the ground is level, then by definition this angle has to be 90 degrees. So you can see this starts to look like problems that we've seen before. The included angle is 60 degrees, and so now to solve this, to find height h, we're going to label the two legs of this 90-degree triangle. And I'm going to call this leg on the bottom side A, and that's for adjacent. And I'm going to call the leg over on this side, which they've labeled as h, side O. And that's just to remember, that's just to remind us that this is the side of the triangle that is opposite the angle of interest. Okay, so if I actually drew that side of the triangle, and it'd be right along this line here. So the question is, how do we relate side O, side A, and the hypotenuse of 40 feet? Well, you might think, oh, maybe we could do a Pythagorean operation on this, but the problem that you run into is that Pythagorean theorem will only work if we know the hypotenuse and one of the sides to get the remaining side, so that's not going to get you there. What you're going to have to use is a trigonometric function. And if we think about what we want to know the opposite side, and we know the hypotenuse. So what trigonometric function relates opposite to hypotenuse? Well, there's a little mental trick you may have learned if you took this in high school. So, ka, toa. And so, ka, toa indicates the relationships of each of the trigonometric functions. So the sine represents the opposite over the hypotenuse, the cosine represents the adjacent over the hypotenuse, tangent is opposite over adjacent. So if we look, we're trying to relate opposite to hypotenuse, right? Opposite is what we want, hypotenuse is what we know. So if we look, the sine function is going to be our function of choice. So if we write the problem out as it's been stated to us, sine of 60 degrees equals, what does it equal? It equals the opposite side, which we don't know, divided by the hypotenuse, which is given as 40 feet, the length of the ladder. Now, the way you fix this problem is we multiply both sides by 40 feet. That gets rid of the denominator on the right side, so we do 40 feet times sine of 60 degrees equals our side opposite. Now, what is the sine of 60 degrees? I don't know, but I can either go and look it up in a trig table, or I can use a scientific calculator, like you'll find on the computer. So let's do that. 60. Now, I'm going to use the sine function, but a couple of things that are important to be careful of. You'll notice that the calculator is in the degrees mode. You can also do angle measurement in radians. However, none of the tradespeople's tools measure angles in radians. You can't set the miter box to 1.5 radians. The carpenter is going to set the miter box in degrees. So make sure you're in the degree scale, because otherwise none of your answers are going to come out right. The other thing is, this is a fairly sophisticated calculator that comes with Microsoft. They have hyperbolic trig functions, which we will not use in this course. They're denoted by an h at the end. Make sure you're using just the regular old sine function. So the sine of 60 degrees, I put in 60 and I click sine, and the calculator tells me that this is the sine of 60 degrees. So it's a lengthy repeating decimal. I'm just going to leave it on the calculator as it is. What am I multiplying sine of 60 by? I'm multiplying it by 40 feet. So if I just simply say times 40, what we find is that 40 feet times the sine of 60 degrees is 34 feet about 34.5 feet. Okay, so let's say 34.6 feet equals the side opposite. Now let's think about if this is reasonable, that this should be 34.6 feet. Well, it probably is, because it can't be any more than the hypotenuse, right? The highest you could reach with this ladder would be straight vertical, and if the ladder is straight vertical, you could get to a height that was equivalent to the length of the ladder, but we can never get that ladder straight vertical. So the answer is reasonable, and maybe the moral of the story here is that you can't get to a 16-foot window with a 16-foot straight ladder. You need a ladder that is some function larger than the some amount larger than the height you're trying to get to. In fact, we could run a little calculation. If you think about the NFPA specified climbing angle of 70.5 degrees. So NFPA says this ladder is to be 70.5 degrees from the ground. Let's say we had that 16-foot straight ladder. How high could it reach? Well, again, we're trying to relate the opposite side to an angle and a hypotenuse. So again, it's going to be, in the real world, it's sine of 70.5 degrees, the climbing angle of the ladder, times the length of the ladder, 16 feet, is going to equal the height that we're able to achieve. If we pull the calculator up, and we'll clear out our previous calculation. 70.5, take the sine of it, times 16. So we find that that 16-foot ladder, if it's climbed at the appropriate angle, is only good for about 15 feet in height. Now, a word of caution on that. Aerial ladders that you find mounted on top of a piece of fire apparatus are rated not by the length of the ladder, but actually by the height of the tip of the ladder when fully extended. So a 100-foot ladder will, a 100-foot aerial ladder really will get you 100 feet in the air. But a 16-foot ground ladder will not get you 16 feet. It'll get you a shade over 15 if it's climbed at the correct angle. That concludes our discussion of problem 1. We'll have a look at problem 2 in the next video.